My name is Philipp Mittermaier. I'm an anesthetist. I work part-time at the company called Mittep AB, which I founded in 2011. And the other part is still in clinical practice at the Queen Silvia's University Hospital here in Gothenburg. We've developed a novel method and a novel simulator for the practice of endotracheal intubation. So endotracheal intubation today is still the safest but most complex way to secure a patient's airway. And despite anesthesia being very, very safe today, failed intubation is still the leading cause of anesthesia-related death today. Obviously, everyone needs to train, but the training methods we have today that are not patient-based are not very interactive, and they do lack the ability to multi-scenario train intubation. What am I actually talking about? What is intubation? Many here have had an operation, and just about half of all of those that have an operation are usually being intubated. And the intubation process is placement of a flexible rubber tube in the patient's windpipe, the trachea. That's an unpleasant procedure and requires deep unconsciousness. So it's either anesthesia or the state after a serious accident or trauma that's required. That also means that the patient can't breathe. And so following that is that the anesthetist should succeed in placing the tube into your windpipe, because otherwise brain damage or hypoxia and in worst case death would be the consequence. I prepared an example what could happen. Let's say a 25-year-old patient presents for a day surgical case at a minor day surgical center somewhere. He looks healthy, but the anesthetist runs into unexpected intubation difficulties. And despite doing everything in his or her might to solve the problem, the patient is exposed for a prolonged time of hypoxia, and brain damage is being developed as a consequence. So that's unfortunate and might not be eliminated by better training in every way, but then studies suggest that non-adherence to algorithms and lack of training is responsible for a major part of anesthesia-related deaths due to failed intubation. So the problem is that we don't have access to a large number of suitable patients, which would be healthy 25-year-olds that are not having any comorbidities, that are suitable for practice with students, junior doctors, and nurses. But then that would also require a teacher being present at the bedside and helping the trainee to develop a good technique. And what's more is that once you've learned intubation, you still need to practice intubation every year to maintain your skills. This is not done today, and as a consequence of that, many providers probably are not that sufficiently trained to perform intubation in especially difficult cases. And other consequence of this is that especially in departments where you are not intubating on a daily basis, like the ICU or the emergency departments, critical incidents are quite common. This is UK data, not Sweden, but still I would guess that the data in Sweden is similar. So it's quite a high number of cases, and this number in the operating department would be like 1 to 5,000, so it's quite a high number here. And another consequence could be that intubation, even though it's indicated in a patient, might be delayed because personnel will wait for another practitioner who is more experienced or qualified to come and perform the intubation. In the operation department, it might interfere with your schedule, and it's unfortunate if patients need to be deferred to the next day or another week for the surgery because there wasn't enough time. Today, unlike other specialties, no periodic revalidation and skill assessment is in place, and that's because there's no machine or no method to do that. So the needs of the anesthesia community would be to teach basic skills to many, maintain skills, and educate accident, emergency, and ambulance staff. So that's quite a lot of trainees. Here you actually see a student practicing on a very early version of our model. Also, pediatric intubation. Tendency today is that the children's pediatric cases are being gathered in large centers. And that's obviously for the benefit for good patient care. But it also means that anesthetists in other hospitals that are not specialist centers can't train that much. And despite of that fact, I still think that every anesthetist should be able to intubate small children with good confidence. For example, if a child gets into an accident at the Linney Square here down the road, obviously the ambulance will take the child to the Sahlgrenska University Hospital, and you obviously expect that the patient can be intubated without problems. New methods come up today. Video laryngoscopy is a big novel thing that's spreading like fire in all anesthesia departments. And also algorithms change every now and then. And non-adherence to intubation algorithms and handling of difficult airways is quite a significant source of errors today. So intubation drill should be practiced too. Our solution is the anesthetics intubation simulator, which you see here. It's an augmented reality training system which uses normal instruments in a life-size head. It's one system, but it has several functions. It provides different airways, multiple scenarios. It's interactive, and that means that you can train on your own. And it's available for both adults and children training. Here you have a picture of a normal airway. This is the opening of a normal trachea, the windpipe, and this is the instrument you use to move the tongue out of the way. On the same screenshot, you have a video laryngoscopic picture, which is taken from a virtual camera on the tip of the instrument. And on this picture, you have a patient that has swollen tonsils, as in tonsillitis, severe tonsillitis, or in a cancerous condition. And you see the opening of the windpipe is quite small, and placement of a tube might be very difficult in this case. So the benefits of our system would be that it provides training, it's interactive, reduces teacher time, it's self-instructive, portable, and therefore the trainee can take it anywhere he wants to and train when it suits him or her. Therefore, it's time efficient, and since it provides feedback, the good thing is that you can come back to the training system and look after 3 months or half a year. How have I done? Have I learned anything? Have I maintained my skills? Or have I not developed any new skills during the time? As a consequence, in the long run, this means it could improve medical care, and potentially save lives as well. Here's an example, a real-world example. This is an accident scene, and the patient here, let's say that he has sustained severe damage from the accident. So the first to respond to the scene are paramedics, and if they are qualified to intubate the patients, they may deliver the appropriate care right here. And if they can't, they will drive as fast as they can to the emergency department and have him intubated here. Or the emergency department can't, and they will call the ICU or anesthesia staff to perform the intubation. But of course, this means a delay in time, and not always does it mean that the patient gets harmed, but it can mean just a thing like the patient developing a pneumonia, which may mean a week or 2 in hospital, or can lead to diminished lung function. So obviously, training of paramedics and ED staff would be beneficial. So once more, the product here is software-driven. The instruments are tracked by an electromagnetic systems, so we're actually evaluating what the user does. We're not making a new doll that's as good and as perfect as ever, but we're actually looking at what the user does, so that's a novel approach. And the computer does calculate a few parameters from that, so it's possible to use the system to maintain skills. So the mission we have is to deliver quality intubation training to anesthesia, ICU, and accident and emergency staff all over the world. Well, obviously, we will start in Sweden, but still, departments, they can rent, buy, or lease our equipment. And since it's software-driven, it makes pay-per-case or subscription solutions easy to make, and it's also easily to upgrade and update via an online service. Our first markets are Sweden. We actually have booked quite a lot of customer meetings, and we will start doing that next week. And the other markets that we are planning to venture in is Germany and the UK. Currently, there's no direct competition. The first customers we're looking at are specialist training education lines, as in nursing training or specialist anesthesia training. Current simulation trends in healthcare are on our side, and the financial pressure the healthcare system is under to develop cost-efficient training and save money is also on our side. As I said, sales in Sweden are commenced, and we plan to enter the UK or Germany next year. There are a couple of companies that make simulation equipment, obviously. They're quite big, CA Healthcare, Lärdal and Gomard, but their equipment mostly focuses on group training, as in training scenes and interaction between providers. And our product and our MUC software can easily be integrated into existing equipments and augment functions there. The company was founded in 2011. That's my name here. We don't have any debts, no royalty payments or agreements, and we have applied for a patent for our method. What we're looking for is distribution and licensing agreements or help, and that obviously would enable us to venture into new markets faster and take advantage of the lack of competition that we have currently. Feel free to contact me later on as a meeting here or visit our homepage. Thank you for listening.
Thank you, Philipp Mittermaier. So we have time for questions even here, and 2 mics. I can start with one maybe. So it's very dramatic pictures that show us, and when things go wrong, it's really... So what is the most common problem or mistake that is done in these procedures that causes these problems? Or?
Well, usually the problem is that the anesthesia provider will receive a patient and might not examine him or her properly before the anesthesia and might miss a few clues that would hint to the airway being complicated. So being prepared is the A and O of a good intubation procedure. It's just as important as the same procedure. And then obviously to have the mental preparedness for plan B or C, that you know what you do.
Thanks. So do we have any... I can add one more. I thought it was really... you had this interaction with what happens on the screen, but is it... I guess there is no force feedback.
No.
Is that something that you want to have in the
Well,
next version or something?
I was looking at force feedback. Actually, the first version of the software we did was connected to a head that had a lot of actuators and balloons in it, so they could alter the conditions physically. But I did tests, and I did not find that users actually needed that extra feedback, so they were more reliant on visual clues and visual guidance of the airway rather than getting haptic feedback.
Great. So then I have another third question. I understand you have made these prototypes yourself with a 3D printer.
Yeah,
is
that's
that right?
True.
So that's really revolutionized. You can really do a lot of stuff today that wasn't possible. So what is your experience?
The first experience I did, I bought window dressing mannequins, and I would just modify them just to test and play around with them. And so I was thinking, what should I do? How should I manufacture my mannequin head? So 3D printing was a perfect method to do that, because I already had drawn the model that I use in the 3D software, and that could easily be transferred to the 3D printing software, and then in a matter of one day you have the model in your hands. It's very nice, and it's actually not that expensive.
Yeah, everybody should have one, right?
Everybody, obviously.
Thanks a lot. Good.